unit of electric field is, so we know that electric field E, that is nothing but F by Q. F is the force and Q is the charge. So unit of F is newtons and Q is coulomb. So Newton per coulomb is the correct answer in this case. Let's see the next one. Yes. So electric field due to a positive charge is radially outward. Let's see the next one. Electric field is real. That's true. Electric field lines are imaginary. See, so the question says here, electric field due to a 10 coulomb charge. So let me just write what is given. Q here is 10 coulomb of charge at a distance. So R is given here as 3 meter. So straight away we have a formula, E is equals to K Q over R square. So K is nothing but 9 into 10 to the power 9. Q, the charge, is nothing but here 10 coulombs, and R here is 3. So 3 square is 9. So we will get 10 to the power 10 Newton per coulomb. That's our answer, option A. Electric field due to 100 microcoulomb charge at a distance of 3 centimeter. So let me write here Q is 100 microcoulomb. So micro is 10 to the power minus 6 coulomb, and distance, let's write it R as 3 centimeter, which is 3 into 10 to the power minus 2 meters. Now the electric field E will be nothing but K Q by R square, and that will be equal to, what is our K? 9 into 10 to the power 9. Q over here is 100 into 10 to the power minus 6 whole divided by R square. So let's make it as 9 into 10 to the power minus 4. So 9 and 9 gets cancelled, and what we left with here is 10 to the power 9 and 10 to the power minus 6. That's 10 to the power 3 into 100, and 10 to the power minus 4 goes up, it will be plus 4. So 4 and 3 7, 7 and 2 9, 10 to the power 9 Newton per coulomb. That's our correct answer, option B. Electric field due to 50 nanocoulomb. So let's write here Q, that is equals to 50 into 10 to the power minus 9 coulomb charge at a distance. So R will be equals to 5 centimeter. 5 into 10 to the power minus 2 meter is, so electric field E, that will be equals to K Q over R square. K is nothing but 9 into 10 to the power 9. Charge over here is nothing but 50 into 10 to the power minus 9 whole divided by R square, which is 25 into 10 to the power minus 4. Now we can cancel 25 and 50. That will give us 9 into 2, and 10 to the power plus 9 and minus 9 goes, and here you left with 10 to the power plus 4. So 18 into 10 to the power 4 Newton per coulomb. That will be the correct answer, which is option B. Let's see the next one. If the electric field due to 0.1 coulomb, so Q here is 0.1 coulomb, charge is 1 Newton per coulomb. That's our electric field. So E is equals to 1 Newton per coulomb at any point X. So we have to find the distance. R is nothing but X. So E will be equals to K Q over R square. E is nothing but 1. K is nothing but 9 into 10 to the power 9 into Q. Q is 0.1 whole divided by X square. So X square will be equals to 9 into 10 to the power 8, because 0.1 will be 10 to the power minus 1. So I just took it as that. So if you take the root, X will be equal to square root of 9, that's 3, square root of 10 to the power 8, 10 to the power 4 meter. That's the correct answer. So option C. If the electric field due to 10 to the power minus 5 coulomb, so that's our charge Q, that is equals to 10 to the power minus 5 coulomb, and electric field here is given as 9 Newton per coulomb, then find the point X. So let's assume R as X. So electric field E is nothing but K Q over R square. So E is 9, K over here is 9 into 10 to the power 9, charge Q is 10 to the power minus 5, and R is nothing but X square. So X square will be equals to here 9 and 9 gets cancelled, and 10 to the power 4 we left with. So X is equals to 10 to the power 2 meters, which is 100 meters, and that is option C. So here the question says, if the electric field due to a charge Q, so let me write here the charge is Q at a distance R equal to 3 meters, and E value is given here as 9 Newton per coulomb. The value of Q they are asking. So let me write the formula. It is KQ by R square. Now what is electric field here? 9. K is 9 into 10 to the power 9. Q we are looking for, and R is 3. So 3 square is 9. So that will become 9 into 10 to the power minus 9. That will be our Q, or you can say 9 nanocoulombs. That's option B. So question over here says, if the electric field due to a charge Q, so capital Q is Q, at a distance 9 meters, so R is 9 meter, and the electric field E is nothing but 5 into 10 to the power 9 Newton per Coulomb. The value of Q they are asking. So electric field E is nothing but K Q over R square. And electric field is what? 5 into 10 to the power 9. K is 9 into 10 to the power 9. Q we are looking for, and R is 9. So 9 square is 81. So we can cancel 10 to the power 9 both the sides. So it will be 5 into 81 over 9. That will be our Q. So 9 9s are 9 5s are 45, and 45 Coulomb is the answer for this option C. So the question over here says a 2-point charge is plus 5 into 10 to the power minus 19 Coulomb. So let me write here, this is 5 into 10 to the power minus 19 Coulomb, and plus 20 into 10 to the power minus 19 Coulomb are separated by a distance of 2 meters. So let's say the gap between the two is 2 meter over here. The point on the line joining them at which the field is 0, electric field intensity is 0. So let's assume that this point over here is point P, where the field is 0. Now if the field due to the charge A at P is 0, let's assume that this distance is x. We don't know this distance. If this is x, then the other one will be 2 minus x. Simple, right? Now since they are vector quantity, first draw the direction. Now if it is a positive charge, the field due to the first charge will be outward, radially away from the charge. For charge B, again it is radially outward, so electric field due to B is this side. Now we can see the angle between them is 180 degree, hence the net electric field at point P will be EA minus EB you can do, or you can do EB minus EA, doesn't make any difference. But we know that electric field at point P is 0 as per the question. So it will be EA minus EB. So if we take EB on the other side, it will be EB equal to EA. Now let's substitute the value of EB and EA. EB, electric field due to B at point P, will be K. Let me put here K. The charge is Q, 20 into 10 to the power minus 19 upon the separation, that is 2 minus x whole square. That will be equals to K, the charge on A, that is 5 into 10 to the power minus 19 whole divided by the separation, which is x square. Let's cancel out K with K, and 10 to the power minus 19 with 10 to the power minus 19. What we left with here is 20, let's take 5 on the left hand side, and 2 minus x whole square divided by x square. So this will be 20 upon 5, that is 4, that will be equals to 2 minus x whole square over x square. Now taking the root on both the sides, it will give us 2, that will be equal to 2 minus x over x. So 2x will be equals to 2 minus x, or 3x will be equal to 2, so which implies x is 2 by 3. Now be very careful, you can also find one more value if you take here minus 2, because root of 4 is minus 2 also, but that will give you a negative value. So here it is x equal to 2 by 3, which is option B. So question over here says 2-point charges. Let's call this as 0.2 Coulomb, and another one is 0.4 Coulomb. They are placed over here at a distance of 0.1 meter apart. The field at the midpoint between the two charges. So if this is a charge A, this is charge B, and let's say this is our midpoint over here. So let's call this midpoint as point P. Okay. Now this positive charge, the field will be radially outward. So this will be electric field due to A, and due to this 0.4, it will be radially outward. That will be electric field due to B. So net electric field at point P will be equals to EA minus EB, we can think of, or you can say EB minus EA. That is just a matter of direction resultant, depending on which one is greater, right? So EA is K QA upon r square, r will be AP, okay. Let me just make it AP only for the beginning, AP square minus K charge on B upon BP square. Now we know that it's a midpoint. So for midpoint, it's the same thing, right? AP and BP is same. So we can take it as K upon AP square. I am taking common. We left with QA minus QB. So now K is nothing but I am just solving it here. So which equals to 9 into 10 to the power 9 over AP. That is midpoint of 0.1. So 0.1 divided by 2 whole square. Okay. We will convert it now within a minute. QA is what? 0.2 minus 0.4. Okay, now we can see that it's a negative, so better we would have done QB minus QA. Okay, that's fine. Okay, so this will be 9 into 10 to the, yeah, anyways we take magnitude, so we will just remove the negative sign. So here it will be 0.01 whole divided by 4. So that, let's take that 4 straight away on the top, into 4 multiplied with 0.2. I am taking the magnitude here. So removing this point, you will get here 100. So let's see what we left with. We left with 9 4s are 36, and 36 into 0.2, that's 7.2 into 10 to the power, how much? 11 Newton per Coulomb. And that's, is there any option? Yeah, option A is the correct one. Understood? 2-point charges, 10 microcoulomb. So let's say this is our 10 microcoulomb over here, and another one is 40 microcoulomb over here. They are placed at a distance of 20 meter apart, right? So there's the point on the line joining at which the electric field intensity is 0. So let's say that this point P is the point where the electric field is 0, and let me call this as charge A and let me call it as charge B. Now electric field due to A will be radially outward, electric field due to B will be radially outward. So electric field at point P will be equals to electric field due to A minus electric field due to B. Now it's already given that EP is 0, so let's straight away put here 0 will be equals to EA minus EB, and take EB on the left hand side, it will be EB equals to EA. Now EB will be equals to K QB upon BP square, and that is equals to K QA upon AP square. Let's take that AP is X, so this will be 20 minus X, right? So K and K will get cancelled both the sides, so K gets cancelled here and here. QB, the charge on B, is nothing but 40 microcoulomb, so 40 into 10 to the power minus 6 whole divided by 20 minus X whole square. That will be equals to 10 microcoulomb, 10 into 10 to the power minus 6 whole divided by X square. Let's remove this 10 to the power minus 6 with 10 to the power minus 6 and cross multiply. So 40 over 10 will be equals to 20 minus X whole square divided by X square. Cancels, and now take root both the sides. So root of 4 is 2, that will be equals to 20 minus X over X. That will be 2X, that will be equals to 20 minus X. And 3x will be equals to 20, which implies x is equals to 20 by 3 meters. That's the correct answer.